of the most spectacular things in mathematics is our ability to rewrite things to make things shorter to work with. For instance, we can have 2/3 times 2/3 times 2/3 times 2/3, or we can simply write it 2/3 to the 4th power. The little exponent, the raised number of 4, says that we're multiplying 2/3 by itself 4 times. When we have a number raised to an exponent, it denotes repeated multiplication. 5 to the 5th is 5 times 5 times 5 times 5 times 5. And that comes out to be 3,125. Be careful. Sometimes people accidentally think 5 to the 5th is 5 times 5. It's not. How about this one on example 3? 7/5 to the 3rd power. That's right, 7/5 times 7/5 times 7/5. And then, of course, we can multiply those fractions together and end up with the result. How about examples 2 and 4? Those are for you to try. Please pause the video here, then come on back when you're finished. Let's see how you did. On number 2, we have 10 to the 3rd, which is 10 times 10 times 10, or 1,000. Number 4, 4/7 to the 5th, we have 4/7 times 4/7 times 4/7 times 4/7 times 4/7, or 1,024 over 16,807. Example 5 shows a mixed number. Mixed numbers must be converted to improper fractions before you can use the exponent rules. Why that is, I'll explain that to you in class. So this is 5/2 times 5/2, or 25/4. So let's see what we have. In summary, we know that exponents are repeated multiplication, and we can write exponents to make numbers a little bit shorter to work with. So far, we've worked with exponents that are positive numbers. How about 5 to the 0? What does that become? Well, anything raised to the 0 power is equal to the number 1. So in our example here, 2/3 to the 0, 2/3 to the 0 simply equals 1. Example 7 shows this very same property. 10 to the 0 power, simply 1. Jumping ahead to example 11, we have 4x squared y to the 0. Notice here that the 0 is only attached to the y. So the y becomes the number 1, leaving us with 4x squared. Please pause the video to try examples 8, 9, 10, and 12. Once you've finished those 4 examples, come on back and let's take a look at your work. Example 8 and example 9 both have a number raised to the 0 power. That comes out to be 1. Number 10 is slightly more interesting. 5 to the 2nd power times 6 to the 0, that's 25 times 1, or simply 25. On number 12, we have w to the 0 and z to the 0. Those two numbers become 1, so we have 7 times 1 times 1. 7, x to the 3rd, y to the 7th. Now, we know that anything to the 0 power is 1. But I know what you're thinking. What if the exponents are negative? What if we have 5 to the -1 or 5 to the -2? Well, let's just take a look what happens here. Going down the list, from 125 to 25 is dividing by 5. 25 to 5 is again dividing by 5. And to go from 5 to 1, we again divide by 5. That means to go to our negative exponents, we take 1 and divide it by 5, giving us 1 over 5. Divide by 5 again, and we end up with 1 over 25. Really, all a negative exponent means is that something is going to move. 5 to the -1 is the same as 1 over 5 to the 1. 5 to the -2 is the same as 1 over 5 to the 2nd, or 1 over 25. Example 13 illustrates this beautifully. We have 12 to the -3rd. Because it's a negative exponent, we can simply move it down. So we have 1 over 12 to the 3rd. And then, of course, we can multiply out 12 times 12 times 12 and we have 1 over 1,728. How about number 14? What do you think happens there? Well, you're right. Anything to the negative power means it moves down. So we have 1 over 8 to the first. Number 15 has a lot of stuff going on. Notice here we have two things with negative exponents. Those are the things that are going to move down to the denominator. We're left with 5 and y to the 5th on the top, and w squared z to the 7th on the bottom. How about number 16? This one's for you to try. See if you can apply the rules of negative exponents and exponents of 0 and simplify this expression. Please pause the video here, then come on back when you're finished. We'll see how you did. Here we have 6 to the negative 2nd and n to the negative 7. Those items are going on the bottom. M squared and p to the 0 stay on the top. Because p to the 0 is simply the number 1, I can just disregard it. That leaves me with m squared over 6 to the 2nd, which is 36, n to the 7th. Number 18 is a little different looking here. Notice we have things on the bottom in the denominator. W to the negative 5th, r to the negative 2nd. Well, a negative exponent always means you're going to move that thing. And so because we have w to the negative 5, w to the 5th will come up to the top. And r to the negative 2nd will come up as r to the 2nd. We're left with w to the 5th, r to the 2nd, over 1. Number 19 is my favorite problem of them all, and this is for you to try. See if you can apply all the rules you've learned about in order to simplify this expression. Please pause the video here, come on back when you're done. We'll see how you did. We begin by highlighting the negative exponents. Those are the things that are going to move. The b to the negative 5, well, the b to the 5th will come down to the bottom. We have 5 to the negative 1, 5 to the 1st will come up. E to the negative 1 also moves up as e to the 1st. F to the 0 simply becomes a coefficient of 1. We have 2 times 5 on the top, that's 10. A squared, c to the 8th, e to the 1st, over b to the 5th, d to the 5th. So here's everything you need to know about exponents. Exponents denote repeated multiplication. 3 to the 4th power is 3 times 3 times 3 times 3. If you have an exponent of 0, the specific thing that 0 touches is what becomes 1. Anything to the 0 power is simply the number 1. Negative exponents mean that things are going to move. If you have x to the negative 5, it'll move down to the bottom as x to the 5th. And that's everything you need to know about basic exponents.